I got a hint from a friend which motivated me to add a new feature to my antenna tool that I shared in episode EP18. It's about antenna matching, and I think there is a little aha effect even for experts. In the video EP18, I shared a tool with you that can be used to relate the most important parameters of an antenna. It might be interesting for you to watch the earlier episode, as the tool has a lot of other interesting features. Part of it deals with the conversion of the return loss, or the VSWR, into all other quantities such as transmission loss, transmitted power, etc. Now we have an upgrade for free. I added the computation of the VSWR, including lossy feeder cables. It's really interesting to see what VSWR or return loss you can expect at the end of an antenna feeder cable. Especially if the cables have a high attenuation, what you can expect at high frequencies. We will calculate examples and also show the results on a descriptive graphic. For further upgrades, please like the video and subscribe the channel. The new tool is also on GitHub. You will find the link below. I changed the cover sheet a bit to make it more specific to the topic. Okay, there is a lot of other features in the tool, but we go directly to the sheet VSWR and return loss, because in this video I will only talk about the new function. For the first example, I want to exaggerate a bit so that the effects are very clear. Well, I should also say now, don't do it at home, because the idea is just crap for a real system. Assuming we are using an RG58 coaxial cable at 435 MHz to feed an antenna. Since the RG58 cable has an attenuation of 32 dB per 100 meter at 435 MHz, there is an attenuation of 4.8 dB at a length of 15 meters. Our antenna in the example has a VSWR of 1.4. We get two output sections for the results. The upper one gives us the figure at the antenna connector, where we see the results of a reasonably good antenna match. More than 97% of the power is transmitted to the antenna and less than 3% is reflected. The lower output section gives us the results for the matching, including the feeder cable, on the side of the transmitter, if you will. Well, you probably expected it. Only 32% of the power is transmitted to the antenna. Like I said, don't try it at home. But what's somewhat confusing is the fact that the VSWR is 1.1, which corresponds to a good matching. Yes, of course, that's good for the transmitter because little power comes back. Okay, now I want to show what happens when the antenna just rusts away or is getting damaged. We use the value 20 as the VSWR, which corresponds to an antenna that is almost non-existent. Of course, correspondingly little power is now transmitted. But we would hardly notice it on the transmitter side, since the VSWR with the value 1.8 is not that bad. I think the effect becomes quite clear with that. Degradation of the antenna would be hardly noticeable with such an antenna feed line. The little tool can help you to better estimate the VSWR you measure at the transmitter side. The second column of the tool assumes return loss and basically does the same calculations. Well, radio amateurs prefer VSWR, electrical engineers prefer to work with the return loss. On the right, we have a small graphic that we can adapt and print out for our own case. We simply use the attenuation of our own antenna feeder cable. Let's say it's 2 dB. And already we get a graphic that we can print out for our purpose. The graph tells us that if we measure a VSWR of 1.5 at the transmitter, for example, then the VSWR at the antenna is actually almost 2.0. If you use 6 dB as attenuation for the feeder cable, then you can practically do whatever you want on the antenna side. The matching on the transmitter side always seems to be acceptable. With the small tool, you can calculate back to the actual matching of the antenna. The insights and the summary. Amateur radio operators and professional RF engineers have the experience that measuring the VSWR or the return loss through a lossy feeder cable is a bit tricky. What you see at the end of your feeder cable might be pretty different from the actual VSWR at the antenna connector. With a high feedline attenuation, you might still see an acceptable VSWR while your antenna is already rusted out. Now we have a tool for the better interpretation of the results. Maybe it would also be a nice project to build a VSWR meter that takes the cable attenuation into account and computes the actual VSWR at the antenna connection. What is your comment about this topic? Just let me know. Now stay tuned and don't forget to subscribe and support the channel. See you soon in the coming episodes.